Good morning, my name is Patricia Soster. I'm a PhD student in Ghent University, and I'm going to present part of my project that's in sound analysis. From sound to signal, identify, classify, and applying broiler vocalization for welfare monitoring. Starting with a brief introduction, we know that the world population is expected to increase in the next years. We can expect as well an increase in animal protein demand with intensification of animal production in a context that we have as well higher number of animals per farm. So the group observation is very challenging, also in a context that we have an increase in welfare concerns. So to keep production, also keep the group observation and making sure that we have welfare for these chickens is very challenging. And we have the increase in the last years of the study of precision livestock farming. That's a set of technology that might help us to control this production. One of these technologies that has been studied in the last years more is the use of sound analysis. In our project, we wanted to start to analyze vocalizations in broiler chickens. To better understand what we had in literature, we performed a systematic review where we evaluated the number of studies that we have in chickens, but also laying hens from 2000 to 2022, and we could find 44 papers. We keep going with our projects, and in the end of my PhD, we updated the systematic review in order to publish. And in the last 2 years, so from 2022 to 2024, more or less, we had a big increase of number of studies from 44 to 57, meaning as well that we have an increase of studies in this area. And we selected only papers that applied to chickens or connected as well with sound analysis. In the systematic review, we had 17 different types of vocalizations, some of them related to respiratory disease, hatchery, eating behavior, some of them related to negative and positive welfare. After selecting and evaluating these vocalizations, we select 4 of them that we could really identify and used later on to keep going with our project. One of these selected vocalizations were distress call related to negative welfare, and 3 of them more related to positive welfare, so pleasure notes, short beep because it's more related to activity level, and warble notes that's more related to somnolence spirit. After selecting these vocalizations, our goal was to develop an algorithm to automatically recognize these vocalizations over time. So we had a trial with 10 chickens per pen, only one pen. We recorded 24/7, and we selected all the vocalizations during this period. And we split these vocalizations in 5 weeks. After that, we evaluated file per file, and we split the files in maximum 3 seconds to make sure that we would find only one type of vocalization per file. And when we had only one of the vocalization per file, or distress call, short beep, warble, or pleasure notes, I selected, and it was automatically selected in another file. Any other type of vocalization or mix of vocalizations we discarded. And the split of weeks was very important because vocalization change over time. So over time, we can expect that vocalizations will decrease amplitude and frequency, and we wanted to make sure that the algorithm would recognize these vocalizations per week. Here we have a nice picture of these vocalizations. First one, just to have an idea how it looks like, distress call. Second one, short beep vocalization, very similar to distress call, but less frequent. The frequency is much lower. And pleasure notes, more related to short beep, but the wave points to the other side, and warbles is a kind of bow type vocalization. After training the algorithm, our goal was to have at least 50 vocalizations per week with good quality, because the best the input, the best the output. We got an average of 95% of accuracy. After this step, we wonder what other type of vocalizations we would have in broiler chickens. So with the other vocalizations that didn't fit the 4 we selected, we performed clusters. In the end, we had 38 clusters, but of course we wanted to make sure that this was really related to broiler chickens. So we performed audio and visual analysis, and 18 from these 38 clusters were not chicken related. So it was human voice or it was the noise of equipment, so it was discarded. 4 of these clusters were very similar to pleasure notes, so we discarded as well, and 2 other clusters related to warble notes. After that, we wanted to make sure that the clusters that were just slightly different but could be the same vocalizations were not selected as different clusters. For that, to turn it less subjective, instead of only visual and auditive analysis, we had the help of Euclidean distance to see how far were these clusters from each other, and after to a certain point, connected as well with the visual and auditive analysis, we consider the clusters as the same or not. So 4 of these clusters were consolidated together, and other 2 clusters were also consolidated together, and in the end we got a final 10 other clusters that could potentially mean other type of vocalizations in broiler chickens during this period of age. But after having the algorithm to automatically recognize the vocalizations in step 2, we wanted as well to check how would be and if we would find baseline patterns for these vocalizations over time, and also we wanted to check if we would have change when we performed heat stress. In this trial, what we had 4 pens per round and 3 rounds that we evaluated and recorded 24/7 from 1 to 42 days. Broiler chickens. Per pen, we had 140 chickens, so because of the size of the pen, we had 2 microphones per pen. When we can see here the waves, red means distress call, green short beep, blue pleasure notes, yellow warble, so we can not really see warble notes during the period, and other type of vocalizations in purple. When we evaluate the 8 microphones per round and also the microphones between rounds, we can see that we can see a pattern of these vocalizations over time, where we see more pleasure notes in the beginning and overall decrease of these waves over time, except by other type of vocalizations that we have an increase from the middle to the end of the cycle. But when we evaluated heat stress, we could not see change in number of these vocalizations when we compared thermoneutral and heat stress period. Heat stress was performed in the last 2 weeks for 6 hours, achieving a maximum of 28 to 30 degrees. In the next step, we wanted to check if these baselines would keep the same in a different setup, but also if they would tell us something when we had disease challenge. So in the last step, we wanted to check if we would find this difference in this type of setup. We had 11 chickens per pen, 1 microphone in the middle, and 3 treatments, 1 control group, 1 coccidiosis, 1 infection bronchitis. We had 4 rounds over time, and we changed the disease according to the room to make sure we did a rotation to make sure that we would find a difference because of the treatments instead of the room. These rooms, they were disconnected from each other to make sure that we had not cross-contamination, and we recorded as well 24/7 from 1 to 41 days. What we could see in this setup is that the pattern of the baseline vocalizations keep the same as previous experiment where we had much bigger trial. So we could see over time a decrease in the overall vocalizations, much more distress call and short beep when compared to the other vocalizations might be because the frequency of these vocalizations are much higher, and might happen as well that we have overlap, and when we have overlap we can select much more distress call and short beep when we evaluate warble and pleasure notes. Warble we could detect it, but very low frequency during the experiment could be as well because of the overlappings, but here where we have only 10 or 11 chickens per pen might mean that indeed we have much less of these vocalizations because we had much less overlapping when compared to the previous trial. Pleasure notes as well, more frequent in the first 2 weeks, and we have a sharp decrease over time. But again, we could see an increase of other vocalizations, mainly from the second weekend onward. When we evaluated period of the day, we could see that the vocalizations are much more frequent during the day, so morning, afternoon, and evening, and we have a sharp decrease at night that's expected. That's the resting period of the chickens. And also important to say that the dark period was performed from midnight to 6 a.m. But when we evaluated this disease, coccidiosis, and infection bronchitis, we didn't see difference in the change of these patterns of vocalizations compared to the control group. We have some take-home messages from this experiment. The first one, the systematic review, we have a large variety of approach, and sometimes it's different to compare the works with each other, because when the papers sometimes they focus a lot on the animal side, they don't really provide a lot of information from technology, and the opposite as well. When we have a lot of information of technology, we don't really have a lot of information about the type of bird, age of birds, and so on. But we could see a high increase of these studies in the last years. So the interest for this area of research is increasing. In the second work, we could see that it's possible and feasible to train these vocalizations and try to find baselines to record over time and try to see difference in different challenges. The broiler repertoire might be broader than expected, so from the clusters we could see 10 different type of vocalizations that could possibly mean new vocalizations, but for that we need, of course, studies to connect the behavior of these chickens with the type of the vocalization. Sound analysis captured consistent age-related and unit vocal patterns. We could see that in the last two trials, that the vocalization have baselines, mainly when we evaluated these four vocalizations, but also for the other type of vocalizations. And it's important that for the other vocalizations, we don't know exactly which vocalization is increasing over time, if it's some clusters of these vocalizations or only one type of this vocalization. And we didn't find a difference for heat stress and disease when we evaluated here in these trials, which could mean that maybe we cannot connect or detect this difference by sound analysis, or could mean as well that we are not really looking at the same at the correct place, because could be that instead of number of vocalization change, we would have change within call types that was not really evaluated in this study. But it was interesting to see that the four type of vocalizations that we used to train the algorithm perform was connected to the most of the vocalizations that the broilers have during their slaughter period. Thank you for all the research wish project for this presentation, and thank you for your attention.